Aloha and welcome to this hopefully brief screencast on form processing in Play. The idea of this example program was that I wanted to understand how to map between a form that included things like checkboxes and multiple selects to an underlying model which had composite models. So we have this model entity called a student, and it has these various fields associated with it. And the idea is that we want to be able to fill out this form or display this form with the values of these attributes of a student entity, and then we could go back and forth mapping to the underlying hobby entity or grade level entity and students and so forth. And as you can also see, this is implemented using Twitter Bootstrap, so I wanted to be able to understand how to do things like lay out radio buttons and checkboxes and so forth in Twitter Bootstrap. And this turned out to result in code that's a little different from what you normally see in the the standard Play examples. So notably, we'll use WebJars to download the dependencies because that makes things easy. We're going to use a late version of Twitter Bootstrap, version 2. Now, since then, Twitter Bootstrap has come out with version 3, which is going to change things a little bit, at least. But what I found with Twitter Bootstrap 2 was because these other things like checkboxes use form control layouts in Twitter Bootstrap that are slightly different from the text fields, I couldn't conveniently implement the implicit field constructor approach that you'll always see recommended for getting Twitter Bootstrap to work. So instead what you're going to see is a set of helper templates for each of the Twitter Bootstrap controls. This is, I guess, a little bit more code than this implicit field constructor thing, but it actually works in the case of checkboxes, which is the first good thing. The second thing is actually it's a lot easier to understand, at least for a Scala novice like myself, than the implicit field constructor approach. And I think for beginning Play Java users, this will be very straightforward to understand. The other thing that's a significant difference is that instead of having the model classes both support model implementation with the backing database schema as well as the form processing, we're going to separate those two pieces of the application out. So there's a separate class that I'm going to implement that is used for transferring information to and from the form, and that's separate from the classes that are implemented for the underlying database manipulation. So this is a little bit more verbose. It's not the way you'd hope things would work in Play, but it's the way that I found that actually works for this particular kind of example. And as a result of this, we're going to have a single validate method. And finally, there's testing with Fluent Lenium, which is nice and hopefully you can use this to understand how better to construct your templates so that you can actually test for them. It also exposes a library versioning problem with Twitter Bootstrap and HTML unit and Fluent Lenium that had to be resolved. Okay, so as I said before, the two big things here is that there's going to be a class called Student Form Helper, which is used only for manipulating the form, getting data from the form and passing data to the form, and then we transfer that information once we've got it and once it's validated over to the model classes. So it's kind of a two-step process with code in two different places. This, I think, makes things a little simpler to understand. It certainly makes you can do things with validation that are harder to do with a constraint-based mode, but it does have a cost in terms of duplication, a certain amount of redundancy in the code. The second thing is that we're going to not use this implicit field constructor design pattern for Twitter Bootstrap. We're going to use explicit field constructors, and that makes things somewhat simpler. Okay, so how do you want to understand the system? The first thing I recommend is that you just bring up a shell after having downloaded the system, invoke play run, And once play is running, you can go to localhost, and here's the form. And the first thing, you could just type submit, and what you'll find is that because the name, password, level, and GPA fields are required, you'll get these nice validation methods. So we can do things like put, Philip Johnson in here and type submit and find, oh, okay, that's great, that one's okay. But we still haven't given a password, so I could put in a simple password and type submit. And actually, you'll see now we're get a better, more helpful error message that says not that no password was supplied, but actually that we have to have 5 characters or more for the password. So we type a few more characters, and we can click a few hobbies. Let's just go out and fill the form. Okay, and then maybe a couple of these, and we click submit. And upon success, what you'll see is that there's this flash. We use the flash technique in play to display that it was successfully created. And in fact, the form is passed back with all of these fields, in their instantiated state. But also, what you'll see here is the string representation for the model instance, not the form instance of a student, but the actual model that would be passed into the database. By the way, this application doesn't actually implement the backend database, okay? But we do have a models directory with model classes, which are set up so that you could just add the appropriate annotations, hook up the database, and you should be good to go. Anyway, the important thing here, just for explanatory purposes, is when you submit a valid form, you can actually instantiate an appropriate student model, and the value of that, or the representation of that guy or a girl, or whoever it is printed out at the bottom of the page. And that's just, you don't do that in practice, but it helps you understand, I think, what's going on. Okay, so that's playing around with the application, and we've just seen that. The next thing you might want to do is run the tests. To run the tests, we basically Control D out of the running server, and we invoke play test. And what you'll see from this is that we run the tests. Okay, so we have 4 tests. They run, they're successful. I'm going to come back to the test code in a few minutes, but I think it's good to do this up front just to basically make sure that your local environment is running the system correctly. Okay, so having done that, we can now start to actually look at the code. I'm going to just do all this in GitHub. The first thing I think is important, or maybe useful to do, is to look at the controllers. There's a single class called application, and there's basically only 2 controllers. One that invokes, there's only a single page in this application. There's a get and a post method implemented. The get method is going to display the form. The post method is going to submit the form. We have a get index, which takes an ID, which is a student ID, okay, and we'll display that student ID, that student's data in the form if the ID represents a valid student. Otherwise, if you pass 0 in there, then you're going to just display a blank form. So let's see how we do this. Remember, I said there's a difference between the model data and the form data. So we have the student form data class, which is what we're going to use as I refer to as the backing class for the form. And we're going to create one of these things by checking to see if the ID passed in is 0. If it is 0, then we just create an empty version of this thing. Otherwise, we invoke in our models class a method called makeStudentFormData, which takes the ID of a valid student and is going to return a student form data instance with the fields in there filled out appropriately for student data. Okay, so given this particular class, it's just a regular Java class with a bunch of string fields. Then what we do is we can fill a form built upon that class with that data. Okay, and now we've got the actual form data, and we're going to pass that into the template for our index page, passing it the data associated with the student, as well as some helper methods. for hobbies, grade levels, grade point averages, and majors, which enable us to create those nice displays. Okay, so the set of hobbies, for example, okay, is actually retrieved from the database. These are not hardwired into our application, but you have a database that contains a set of hobbies, and we in essence show how to we retrieve those from the database, and we use this method make hobby map, passing it the student data to both determine what are the set of hobbies that we want to display in this checklist, set of checklists, as well as which ones should be checked because they are currently associated with that student. Okay, grade level is passed here. We again the set of grade levels is assumed to be retrieved from the database, so we get that here. Grade point average, again, we're going to use a helper method in this package to both find out what are the set of GPAs and which one should be associated with a student. And finally, with majors, again, you can have one or more majors. We're going to have this map of information. In the case of where you can have multiple values, like make hobby map or make major map, we're actually going to return a mapping of values from the student to the actual entity. Okay? So that's how we actually display a form, either without data, with empty data, or with the data associated with a student. The second controller is what happens when we post a form that we filled out. And basically, we're going to use this bind from request to get the data from the HTTP post method and bind it to an instance of the student form data class. We also have a validate method in that class, and so that's going to be invoked automatically by play, which means that once we've completed this particular construction of this form data object, we know whether or not it's valid. And the way we know whether or not it's valid is by calling this has errors method on the form data class. And if there are errors, then we can basically kind of render that same page in the same fashion as we did up here for a standard get. The only difference is we're not going to make these hobby maps or GPA maps because we don't know whether or not, we don't know which of these fields are valid or invalid, and so we're just going to call them with null. Otherwise, if form data has errors is false, then we can do two things. One thing is, the people have submitted a form, the user has submitted a form, so we want to make a student entity from that, right? And so I show how to do that. The first thing is we use formdata.get in order to create a student form data instance out of our out of this form object, okay? And then we're going to pass that to a helper class of the student entity called makeInstance, which takes a student form data instance and creates a student out of it. So now we have this actual student. Normally we'd want to now persist this to the database or do whatever the heck we want to do with it. In our case, since we don't have a real database, all we're going to do is basically add this flash invocation so that we can print out in our form the fact that we have this student object, what it looks like, and now we're basically going to do again one of these index.render things, passing it the form data and the actual information that we just got. Okay, so that's the way the controller works. It's pretty straightforward, hopefully. If you want to just see how this is wired up, it's very simple. There's a get and a post. The only thing that's the least bit kind of interesting here is that we have a default value of 0 for ID. So if you don't specify that in your actual URL and you just retrieve like the home page, you're going to get that ID equals 0, which, as we saw, is going to result in it creating an empty form. Okay. By the way, there are some IDs that you can pass, and oh dear, I'm sorry, I'll fix that. But if you look down here, you can see that we have this kind of fake database. Okay, so I said there is no backing database, yet we're referring to, pre-existing hobbies and pre-existing grade levels and so forth. So as is typical with these kinds of things, what we're going to do is we're going to just fake that we have a database by creating an in-memory list of students and using a static block to actually instantiate these things. And we do the same thing for hobbies and grade levels and so forth. So that's how that works, and it's no big deal. Okay, so just to review, we've got an HTTP GET and HTTP POST. We have a student form data class, which is the backing class for our form. We also have a student class, which is the actual database entity class, and we have two methods: a make instance method and a make student form data method, which is going to support the binding of student form data to students and students to student form data. Okay. All right. Having said that, we've kind of seen the we haven't seen the student form data class. So actually, let me first go into. Well, actually, I'm sorry. Let's now look at our models. Okay, I'm just going to follow along with my own description. Okay, here's the models package, and this should be very easy to understand because there's really not a lot to it. We have students. Students have a bunch of private fields which contain their internal components. Some of these are primitive values, and some of these are themselves entities, and some of them are actually data structures or lists of entities, and some of them are required and some of them are optional. However, that required versus optional is not done through annotations here. It's going to be done implemented through the validate method in the student form data instance, and that's a difference from what you've normally come to expect from play things. The reason why I didn't use annotations is because I couldn't get them to work. Okay, and as I'll say repeatedly, if you can implement this in a better way, I'd love to see a pull request for that. So anyway, you can see there's a bunch of getters and setters to get the various fields. Here's the make instance form where we take a form data object and we create the actual student entity out of it. Here's the fake database and so forth. Okay, I'm not going to go through all of these because they're basically all super simple. All of them are going to have this kind of fake database and a set of fields associated with them. Okay, so that's the models package. The views package, okay, is where things is going to diverge a little bit more from what you're used to, particularly if you're used to that implicit field constructor approach. The idea is that we have an index and a main. These are exactly like what you've always seen. We have a parameter where we get the student form and then some maps and of the values of hobbies and which ones are actually associated with the particular student that we're trying to display and so forth. And we have this flash thing, and basically we're going to have this form, and then we're going to have a template called field set. So let's go back here and look at the field set. By the way, Jason Pearson was the one that implemented a lot of this stuff as a pull request to my prior play kludge example. So thanks to Jason for showing this. I think it's a kind of a nice approach. So we have a field set, and this is where things get very bootstrappy, okay? Because Bootstrap wants a field set, and so it's implemented here. Along with the the submission buttons, and then we have a bunch of Scala templates: a text one, a password one, a checkboxes, radio buttons, select for each of the different types of fields. Okay, and then you pass in the appropriate values here. And so when you go into the Bootstrap area, here's where you see all of these individual templates for the various kinds of controls that Twitter in the form that Twitter Bootstrap 2.3.2 wants to see. Okay. The other thing you'll notice is that for testing purposes, oftentimes I'm going to supply an ID field here, which isn't strictly necessary for running the system. but it's very necessary in order for Fluent Lendium to find the particular control that it needs to set. Okay, so you can read through this, and this is all, I think, pretty easy even for a Scala novice like myself to understand how this works. There's nothing complicated really going on here. So you can look at checkboxes. Another one is like radio buttons, and just click through. And again, the other nice thing about these templates, thanks to Jason, is that they have nothing to do, they are not specific to this particular application. There's nothing about students or anything in here. So this is a directory of code that you should hopefully be able to take and use for your own Bootstrap display if you're trying to do things like radio buttons, checklists, and so forth. Okay, so let's go back to here, and the other part of it is we talked about this backing class for the forms, and it's in the FormData sub package of views. Here's what the code looks like, and the code is pretty simple. The basic thing is, because it's a backing class and because Play requires backing classes for forms to have public fields, it's like, fine, we'll do that in this case. So here's all the public fields with strings or lists of strings as their components, and there's a public NOR constructor, as well as a helper constructor for creating one of these suckers from a student instance. But the big part of this, the most interesting part of this method, is the validate method, which returns a list of validation errors, which is going to be called implicitly by the Play framework when you do the bind from request call in your controller. And so it's going to run through and do all our validation checks. All right, so our student form data instance is going to have a valid representation of a student if we get out of this validate method without any validation error instances being created. Okay, so now let's go through the tests. There's this thing called the page object pattern. You can look at that if you want to on your own time, but the idea here is to start by looking at the index page class, which is it's the page object pattern implementation, or we use the page object pattern to implement this class that represents the behavior associated with testing this particular page. And there's nothing real subtle about it. We will always pass a student ID in here. We pass 0 if we want a blank form to be filled. We pass another number if an actual student ID if we want the page to be filled with that student's information. We have an isAt method, and then we have a bunch of methods to set the various components of our form. And I think this will be useful to people who want to do form testing, because it took a little bit of time to kind of work all this out about how you do multiple selection or single selection or checkbox selection. And it's not, there's no rocket science here. They're all one-liners, but it's hopefully good reference material for you. Finally, we also have the behavior of wanting to know whether or not our form is indicating success or failure of a submission, so I have 2 Booleans here. Okay, so that's our index page. Now the actual tests are located here in this view test class, and we have 4 tests. One, which is just simply going to create an index page, go to it, and check to make sure we got there. That's just the kind of sanity check to make sure things are functional. Then this test is going to create a page, go to it, check that we're there, submit the form immediately with no data in it, and there's no data in it because we're passing the student ID of 0, which is to indicate we don't have any data. And now we check to make sure that the error message is actually being displayed at the bottom of the page. Okay? Remember, we ran all these before and they all passed, so this presumably is doing what it claims to be doing. The next one is we're going to pass in a student ID of a valid student. Okay, so that's going to fill out the form on this page with valid data. We're going to go to the page, check to make sure we're there, submit the form, and this time we're going to hope that we get the success message at the bottom of the screen. And then the final test is to illustrate how you can actually do the form filling out manually. So we start off with a blank page, and then we go to it, we check that we're there, and now we start setting the name, the password, give a couple hobbies, set a grade level, select the GPA, provide a couple majors, submit the form, and then check to make sure that there's the success message being displayed. It turns out that while debugging this, it was kind of helpful to print out the page source after the submit just to see what the heck the system was thinking. And so I just keep that in there as a hint to any of you developing your own tests. There's a lot of different ways to do it, but that was pretty convenient for me. Okay, so that's the tests. I want to let you know there's a little gotcha with this, which is that in order to do these Fluent Lendium tests, we have to use HTML unit. Okay, so if you look at view test, what you're going to see all of these tests pass HTML unit to this as part of the class that we're instantiating for testing. And the problem with that is that HTML unit requires a version of jQuery no later than 1.8.3. So it's got a bug in it. They don't currently support the most recent version of jQuery. On the other hand, when you just try to straightforwardly import Twitter Bootstrap into Play, if you use the latest version 2 version, which is 2.3.2, you're going to get jQuery 1.9.0. So you need a little bit of magic to make sure that you get the right version of jQuery. And so here's how you do it. You specify 2.3.2, you exclude the jQuery from there, and then you manually import 1.8.3. Okay, you do that, then life is good. Okay, and to conclude, I don't really like the fact that there has to be these two representations of students, but I couldn't create a form that worked appropriately without doing it this way. I'd be interested to see folks that could come up with that version. Another part of it which I don't like that much is the fact that we have this validation method in the backing class for the form, and then there's other places in the code where I wrote a method which I basically, in the Java docs, say assumes that valid data is being passed here. And that's, anytime you make an assumption like that, pretty soon someone's going to violate it. So I don't really like that. I think that's a design flaw in the construction of this system. If someone can come up with a version of this system that actually fixes that, I'd be delighted to see it. No one's shown me how to do it yet. So I've tried things like custom data binding and couldn't get it to work correctly. So I encourage folks to fork this code and try to improve it, and I will definitely look at pull requests and we'll make the changes if they solve these problems. This started as a system called Playform Kluge, which I posted to the group, and then Jason Pearson provided a nice pull request to make it better. Hope you enjoy it.